Okay, thanks very much for the opportunity. I'm grouped in the observations section of EVE, of this workshop. So I will talk about observations, but I will also offer some observations from the perspective of Destination Earth, which is an existing project with a similar philosophy actually as EVE, for EVE. So it's all about observations. I want to take a step back also to relate to what we've seen before in the two talks, but also to other sections in this workshop. I think the ultimate core of EVE and Destination Earth actually similarly is an information system, and it's a new information system because it brings together things in ways that we haven't done in the past. And in rough terms, it's the layers that you see here that you're familiar with. They take different levels of expertise. They represent different abstractions of information or data. And the vertical is important, how you bring those together. And they roughly relate to what Björn had shown in his pyramid on the data, information, and knowledge, I believe it was, in his presentation yesterday. And important is what you can do with it. You know, what you do with this information, regardless of what the information is for a second. But important is interaction across all levels. And that may be rerunning a model if you need to. If you find that an adaptation requires irrigating vast areas or reforestation, you might need to rerun your entire modeling system. If it's more at a higher level of what you care about and what needs to be interacted with, it's a different kind of interaction level. But ideally, you do all of this in real time, in the same system, not having to worry about the technology that sits behind. Okay, that's ideally what we want. And ideally, even on top, we have something like a ChatGPT or an EVE GPT, and you can talk to it. You know, that will really help because convenience, convenient access to information, and interaction with the information is really important. So, yesterday, Jensen's miracles sit in this hierarchy somewhere, you know, his 1, 2, 3 on HPC machine learning, interactivity, his interpretation of digital twin. They sit at these levels, but it's really important to bring all this together. So it's really an unprecedented level of new models and the way we use observations. It's tying this to impact sectors, so tying the physical world to what it means for us at local level, from global to local level, for example. And then the real trick is to interact with it, so you can play. And I think the fourth miracle that he didn't mention is probably that language level that we should also talk about when we talk about EVE, because I think really that will make a difference in impacts. And I think only with such an information system we can address some of the statements that we've heard on yesterday by Björn, for example, the combination of a new quality of information tied to a new way of interacting with information. What Deborah has said, you know, information alone is not sufficient. You know, need to be trust. You need a delta in impact. How do you create this? You need it to be trustworthy, an authoritative voice at some stage. What Aroma had said about, you know, we need to translate global simulations into what it matters for an individual or a city or decision maker. And lastly, Tim, of course, you know, the quality of present climate information is, he would say, utterly insufficient. So this is a figure that is in the white paper that most of you have read, and that shows this kind of thing in a different way, this philosophy. And of course, observations are part of it. And I believe actually, if we don't have an information like this, that is conveniently cutting across these levels and adds that level of interactivity, we will not extract the full value that we invested in our high resolution simulations and in all these observing systems that we require. And there's a lot of questions about interoperability, data access, fair, you know, open data, open philosophies, and these kind of things. So in that system, there's of course a lot of traditional ingredients. You know, it's physics-based models run at high resolution. There's observational constraints. There's data assimilation methods that we know well. And there's that part that Björn described as machine learning inside, which helps accelerate everything in the traditional world and produce shortcuts, adds information, but it's basically machine learning inside basically relates to the traditional system. And there's lots of very new things, which is that fully interacting workflow and data flow mechanism that I mentioned, that you actually don't want to do this just on one system somewhere, but you want to do this in a federated digital infrastructure across countries, ideally. And only then, and you want to be able to export that to countries that don't have any infrastructures, actually, and access that via a website or a laptop or something. You want to have fast updates, not do this only 5-6 years or something, and all of this requires machine learning on top. So I believe actually machine learning inside and on top, I'm going to come back to that later about lessons learned from Destination Earth, will be the key for many of this. Without it, I don't think it's going to work, actually. So something on observations. In terms of climate monitoring, we use observations all the time. And this is one of the basic ingredients and investments for machine learning on top, because machine learning on top is only as good as the training data that you provide it with. And I think we as a community, as a weather and climate community, we're actually really good at producing these reference data sets. So there's data records, observation only, that space agencies do, and observation networks or infrastructures. But probably the most popular ones are reanalyses, and Carlo is here for Copernicus Climate Change Service. So this is numerical models constrained by observations through data assimilation methods. And it's by far the most popular product of the Copernicus Climate Change Service in terms of downloads. And you have, back to 1940, I believe now, the latest reanalysis as a reference data set for how our climate evolved. Described at like, I don't know, 15 kilometers or 20 kilometers resolution. And that is also the most popular data source for machine learning on top, as we know it and as we've seen. So providers are space agencies, NWP centers as part of climate services. Like CMIP, they have like a 5-year renewal cycle maybe, and they're also heavily constrained by computational resources. So one option for where Eve can play a role, and I'm going to come to the next slide what it can do on top of that, but one role Eve can have is actually as a platform provider to these existing services to make what they do better and faster and more open. So enable the digital technology and this nice, information system and help them. They deploy your next reanalysis on the Eve platform and do it every other year and not every 5 years, something like that, So that would be one option. Another option is, of course, in this machine learning logic that you apply something what they do for climate change, and then you add things like wider range of scales. You focus in on specific applications. You tie atmosphere to a flood reanalysis or farming reanalysis. You use IoT observations that the standard weather systems don't assimilate these days. Use a lot more observations, and therefore, prove that the investment in these observations has been worthwhile. This is why I have a double exclamation mark in there for machine learning. Actually, you could also do something that will really accelerate producing these reanalysis, and use actually machine learning to represent the entire data assimilation process. If I would still work, this is where I would invest actually. Must-haves for this are that you have data assimilation type methods, but this is something our community is really good at, our publicly funded community is really good at, to create these best reference data sets and accelerate what existing services are doing. And and machine learning, of course, obviously plays a role in there. We have spoken about interoperability of data and software. That's important for these. Data sharing, I think Jana has just mentioned this. Some of the data formats aren't agreed. There's no real exchange processes in real time, for example. Certain data sets you can only receive after many years when they're actually not interesting anymore. And you have to agree on protocols and reference data sets. And on all these 4 points in the must-haves, I think Eve can really make progress and drive the train in the observation world. But observations are also important for climate projections, actually, as inherited information. For example, when you talk about what Jensen Huang showed based on Björn's GTC talk, where you interpolate between checkpoints in climate trajectories with machine learning, and where you learn some of the structures, the downscaling or the structural information, even physically structural information in these windows from past periods and observations informed, and then project that into the future. So there's a role for observations there as well, but that is certainly something where where Eve can make incredible progress, because that has never been done before. Same what Thomas Jung is doing with storylines, where you project past events into the future. So you take a past event like a heat wave, where you understand, of course, the dynamical constraint of why this heat wave happened. So the weather pattern, like a blocking that promoted that the buildup of that heat wave. And then you use that knowledge to constrain future climate simulations. So you impose a dynamical constraint on a future simulation to recreate that in a +4-degree world, or in a +2-degree world, and see what happens. And then you project it down to city scale and say, you know, what's an event like this projected into a world 50 years from now mean at a city level somewhere where it matters, you know? So these kind of stories are observation informed, of course, based on simulations, but novel things that Eve can do that don't exist yet. So to the second part, observations related to Destination Earth. In case you don't know it, Destination Earth is an existing project. I will say something about the philosophy of it, but it's very similar to Eve, even though Eve does more things. I'm going to come to that, but basically Destination Earth was built on the same ideas from the same people. It is expected to be a 7 to 10 year flagship activity funded by the European Union. It has received 150 million, which is not so bad, you know, for a first implementation phase of 2.5 years. It's implemented, or it's being implemented together by European Space Agency, the Center, and EUMETSAT. And the logic is kind of shown in this graph. It is also looking for international collaboration, but it is, you know, as it stands now, a self-contained, a fully funded project. We're presently negotiating its continuation. So where does it come from, and why am I mentioning Destination Earth? And I mentioned already, you know, same history, same authors kind of thing. And I want to go back to the Shukla and Palmer workshop at the center, actually, about 15 years ago, and we're closing the first iteration of that circle, of that cycle now in July 2023, 15 years later, where most of it started. But there was a couple of other things in between. Maybe the most important ones are the ones in red here. And as time went by, the ideas developed as well. So initially it was probably mostly a kilometer scale climate simulation tied to a big computer kind of thing that then extended further. So everything that comes then in text is added on top. So it recognized then the importance of computational science as a whole. So it really became a computational climate science project more with the next meeting that Tim organized in 2016. Then we had a European flagship proposal going in 2018 that was called Extreme Earth, that was really tying together the science technology impacts nexus that we're discussing here as well. And the sessions were organized like this, not science case, technology case impacts. So that's a heritage from that. Then Destination Earth took that further and created digital twins from that, embedding everything that I've said before. It also added money. And I guess here we're questioning now what Eve is about, and I think it takes a lot of what we've done before in these projects. It globalizes it, and we have to discuss what that means. And it probably targets more the big climate questions than like the slightly more targeted, selective topics that Destination Earth is targeting. So there's clearly an evolution, but I think we have to define it to be clear, and we have to recognize the history. So the core principles of Destination Earth are what you see here. So it's digital twins, new information system. I described that initially. It's again vastly based on physics-based models, generic software infrastructures, user-centric, distributed hardware, both public and privately owned, international collaboration. So a lot of these keywords are actually Eve keywords. So if you look at, if you search for that in the Eve white paper, I guess you'll find all of them. Okay, so that's good. That means our philosophy has stabilized further. Destination Earth is not an outlier, and Eve has something to base on. For me personally, looking at the discussions, the questions, and emails and things, and I guess working groups as well, there's a lot of déjà vus, I have to say. A lot of questions and criticisms that people offer that we had in Destination Earth. I'm not sure we have solved all of them. but also there's a bit of experience, you know, first being it's just another climate model, you know, somebody's hobby that he wants to run on a big machine, you know, unknown science, this kind of thing. The second one I've heard a lot, will draw away funding from existing climate research activities and services. I've heard that a lot on Destination Earth. I don't think that's actually true. We did the numbers. It's wrong, actually. It's the opposite. EVE endangers existing climate service responsibilities, something we're dealing with Copernicus, in our discussion with Copernicus from Destination Earth, for example. But I think there's ways to argue that away. And there's really good opportunities for service complementarity. And I think we need to discuss that in our working groups as well. So more déjà vus. I think actually, you know, if we all believe in the science case, the technology case, that all that is needed, and that we trust, you know, the philosophy of this information system, most of the other things are actually about governance, I believe. Software governance, data, organizational governance, funding governance. And there's a couple of questions which I have formulated here. I'm not going to answer them, but I'm putting in brackets underneath the way we deal in Destination Earth with it, which also means same questions, maybe similar answers actually. So how to create sustainable funding and funding coordination at international level. That needs to be sustainable, not one-off, but you know, for as long as it takes. Very hard. And the envelope, I guess, is hundreds of million per year per hub or something like that. Second, open access membership model. You know, you want to be inclusive. This is not a rich members club. You want to have access for everybody, but you need, of course, funded, some sort of funding model that supports that. So it needs to be democratic in terms of access to the club, but also for knowledge, data, and software. So everything it produces. So you can easily transfer software to some other place that didn't develop it. HPC in data is really hard. In Destination Earth, for example, we have in-kind contribution from EuroHPC. That sounds great. EuroHPC is a 7 billion investment by the Commission into supercomputing at European level. That's a lot of exaflops. Do we have access? Yes, to a certain percentage. Is it easy to get that access to the level and sustainability and reliability that we needed? I'm not going to say no, but it's really hard, and it's not solved yet, even though we started the discussion 2 years ago. You will have the same. Commercial companies is something that Destination Earth doesn't really address. I think EVE really has some mileage here, opportunities that are underexplored and where certain European Commission limitations actually really work to the detriment of Destination Earth. But I think EVE really has a chance here. Then that service element that I mentioned earlier, I think, you know, I mentioned platform as a service, you know, operate some existing things using the EVE platform and then add features to create your own things, you know, is an example of a service complementarity. We have some experience there with Destination Earth and Copernicus, so we can provide that material as well. The other thing that's really important is, in the end, EVE is an information system. It will enable and boost research, but it has an operational component. In the end, it's supposed to provide reliable information on something that people can trust and turn into action. So there's an operational component. At the same time, you will need continuous support from new research, from new technology, from, you know, anything new that you require, new impacts, new societal sectors, social science and stuff. Where does that draft come from? It needs to be funded, it needs to be channeled in. There's, again, questions of, you know, how do you dock a new activity onto EVE in the future? How do you fund that? How do you make sure that actually works effectively in that context? So all these questions are, in a way, EVE questions, but they are also Destination Earth questions. So last slide, a few recommendations on that. So Destination Earth is an existing funded project, and I just discussed yesterday with Christian, you know, about trust and you know, people putting money into something, and we're always asking for money. I believe, actually, at least at European Commission level, there's enough money. And the fact that the Commission gives us more than 60 million a year for Destination Earth right now, without us having delivered anything really in terms of, here, take that, you can push a button, and this is going to happen, is already an expression of that trust. So I think there is money, and I think if we have the right message, we can leverage that. So the the Destination Earth or Eve philosophy evolved over time. It has scaled, as I've shown, but the one question I have for the working groups is actually, in terms of philosophy and content, it's scaling, but as an organizational form, can it actually scale? Can you multiply Destination Earth times 5, and will that still work? I'm not sure about that. So there's a recommendation for that. One more second here. 2 lessons from Destination Earth. We clearly have underestimated the power of machine learning in Destination Earth. So if I would do that again, I would shift that way clearly. And I believe today that because we're trying to do digital twins, you know, this highly interactive, very fast, very accurate kind of thing as an information system, I think without machine learning, it actually won't work. It will only work because of machine learning. So that's important. Lesson number 2, we have underestimated the power of industry. As I said, Destination Earth is kind of public. I now believe actually that big tech companies may help us and to put Eve into action. I'm not sure it works with the entirely public assumption. I'm not sure that's going to work, and that relates not only to HPC but to many other things as well. Yeah, that's it. Thanks very much.